Welcome to CS track. Let us discuss one of the important aspect of the chemical science, that is gram equivalent weight to gram molecular weight to as well as n factor and the interrelation present between the gram equivalent weight, gram molecular weight as well as n factor. Whereas as we are so much aware of one of the term present on the board, that is gram molecular weight. Gram molecular weight, the weight of substance in grams. Gram molecular weight. Gram molecular weight. Gram molecular weight is the weight of substance calculated in grams, which is associated with Avogadro number of molecules. That is the weight of substance. The weight of substance of Avogadro number of molecules. Avogadro number of weight of substance in grams of Avogadro number of molecules is known as gram molecular weight. Avogadro number of molecules is known as gram molecular weight. This is known as gram molecular weight. This is gram molecular weight. That is, whatever substance we are taking, that substance, that molecule's by number we have to take Avogadro in number. Avogadro, as we are very much aware of, Avogadro number is 6.023 into 10 raised to 23. That many number of molecules if are taken and corresponding weight is calculated, that weight is said to be gram molecular weight. That is the weight of substance which is to be represented in grams of Avogadro number of molecules of the given substance is said to be its gram molecular weight. Suppose if I go for hydrogen is a compound, carbon dioxide is a compound. Here the hydrogen's corresponding gram molecular weight is 2 grams. Carbon dioxide related gram molecular weight is found to be how much? 44 grams. Whereas if I didn't wrote any kind of grams extension, then that is said to be what? Molecular weight. That is relative molecular weight, that is said to be molecular weight. Whereas exact molecule weight, instead of grams, here the word unit comes as AMU. AMU is known as atomic mass unit. Thus, gram molecular weight is the weight of substance in grams present for the Avogadro number of molecules of the given compound is known as its corresponding gram molecular weight. Generally, gram molecular weight is represented because as being it is sum of used quantity, represented to make it with the minimum number, to represent with the minimum number, generally represented with the unit, that is grams. If there is no grams, that is said to be molecular weight. Instead of grams, if there is atomic mass unit is present, then that is said to be exact gram molecular weight. That is weight of every particular molecule expressed in terms of AMUs is said to be exact molecule weight. This is Avogadro number of molecules weight is said to be gram molecular weight. If there is no unit, that is said to be relative molecule weight. Thus, gram molecular weight is very clear. But oftenly we are not satisfied with the word that is gram molecular weight. Every case of the reactions, we just not take the direct utility of the gram molecular weight at every instant. We have to take the help of some other technical term. One of the very important other technical term used in chemistry here or there is gram equivalent weight. Whereas what is meant by gram equivalent weight and what makes the interrelation between the gram molecule weight as well as gram equivalent weight, let us have a discussion. Yes. Before going to the gram equivalent weight, we have to discuss regarding the active species involved in the chemical transformations. Suppose if I take a compound, that compound may be an acid, that compound may be a base, that compound may be a salt, that compound may be an oxidizing agent or the reducing agent. Some particular thing is participated in the reaction. As for the chemical reaction is concerned, there is always breaking of bonds, there is always making of the bonds. So therefore, in making and in breaking of the bonds, that bond is nothing but what? Attractions present between the electrons. There is active species, whereas this active species at different places is known with different names. Active species is nothing but what? Generally, it is a direct form of electron. or it can be masked one, that is a masked form of electron. It can be an electron, it can be a masked electron. Sometimes it can be a deficiency of electron, that can be an H plus ion in some cases. This can be OH minus ion in some cases. Like this, these are all generally said to be what? Active species. The many number of active species generated from molecule is reference, and the corresponding weight is said to be what? Equivalent weight. The weight of substance in grams which is responsible for the production of 1 gram. 1 gram stands for what? Avogadro number of active species is said to be gram equivalent weight. The weight of substance in grams, the weight of substance, the weight of substance in grams, the weight of substance in grams which can produces, which is eligible to produce, or which can produce, which can produce, what it can produce? 1 gram active species. What is meant by 1 gram? Produce 1 gram. 1 gram stands for what? Avogadro number, that is N0 by number, Avogadro number. 1 gram of active species as 1 gram of active species. 1 gram of active species stands for, maybe that is 1 Avogadro number of electrons. Some cases it is a masked form of electron. It can be 1 Avogadro number of H plus ions. It can be 1 Avogadro number of OH minus ions. Thus, the weight of substance in grams which can produce as 1 gram, that is 1 Avogadro number of active species, is known as its gram equivalent weight. Known as its gram equivalent weight. Here we always we are always interested in learning of the gram equivalent compared to the gram molecular weight, because active species is responsible. Because active species related equivalent amount of bonds are reconstructed in the rearrangement of the transformations from the reactants to the products. So therefore, active species is very very important. Active species sometimes can be a direct electron, it can be a masked electron. If it is an acid, that is equal to number of H plus ions. Every H plus ion will becomes equal to one active species, because it is lack of electron charge. And every case of in case of Arrhenius bases, every OH minus will becomes equal to active species, because OH minus is having a extra charge of 1 unit, which is a masked form of electron. That is, electron form is represented here as OH minus. Electron deficiency here represented in the form of what? H plus ions. That is, the weight of substance in grams which can produce as 1 gram, that is Avogadro number of active species, is known as its gram equivalent weight. Now this gram equivalent weight and gram molecular weight are interrelated. There are two different terms. One is gram equivalent weight and second one is gram molecular weight. In majority of the cases, these two terms are present. In some cases, gram equivalent weight also becomes equal to gram molecular weight. But in some other cases, gram equivalent weight is different from the gram molecular weight. Though that can be same, that can be different, but they are interrelated one with the other, and they are related with a relation, that is, the gram molecular weight will becomes equal to n factor times of gram equivalent weight. So therefore this gram molecular weight will becomes equal to, this is gram molecular weight, this gram molecular weight will becomes equal to some factor, some multiple. That multiple is known as n factor times of gram equivalent weight. N factor times of what? Gram equivalent weight. So therefore gram molecular weight will becomes equal to some number of times of gram equivalent weight, whereas this number is nothing but what? That is, here from 1 gram molecular weight, the many number of active species produced, that number will becomes equal to n factor. So therefore gram equivalent times of n factor will becomes equal to gram molecular weight. Suppose if I go for an acid, if I go for a base, if I go for an oxidizing agent, then how to decide the n factor? Let us have a discussion. Suppose if it is HCl, HCl generate one H plus ion followed by one Cl minus ion. One molecule is generating one active species, hence its n factor will becomes equal to how much? 1. Suppose if I go for sulfuric acid is a dibasic acid. Suppose if it is generating 2 H plus ions, that is 2 H plus ions followed by SO4 2 minus. As being H plus ion is the active species, here from every one molecule 2 H plus ions are generated, hence here its n factor will becomes equal to how much? 2. Similarly, suppose if it is a base like sodium hydroxide is there, it is going to be giving Na plus ion followed by OH minus ion, hence its n factor will becomes equal to 1. Suppose if it is calcium hydroxide, then it is going to be generating 2 calcium 2 plus ions followed by 2 OH minus ions, its n factor will becomes equal to how much? 2. Thus, n factor is the many number of active species generated from one molecule is said to be n factor. If we divide the gram molecular weight by the n factor value, whatever weight comes, that weight will becomes equal to corresponding gram equivalent weight. Suppose if it is an oxidizing agent, if it is a reducing agent, then the corresponding n factor calculations are, suppose our material is an oxidizing agent. This is KMnO4 is an oxidizing agent. In some cases, this KMnO4 plus 7 oxidation state is converted to some compound of K2MnO4 with plus 6 oxidation state. In some cases, it is converted to some other oxidation state, like here this Mn2 plus is also obtained. In some cases, this is also converted to Mn plus 4 oxidation states. So based on the medium present for the reaction conditions, the oxidizing agent KMnO4 can be converted to a new compound, that is Mn plus 6 compound, Mn plus 2 compound, Mn plus 4 compound. Here from here to here 1 electron exchange is present. Here to here 5 electrons exchange is present. Here to here 3 electrons exchange is present. With respect to the molecule, for one molecule, the number of active species, that is direct form of active species, is nothing but what? Electron. The number of electrons involved in the transformation of our oxidizing agent KMnO4 is given by KMnO4 from plus 7 state is converted to plus 6 state, hence n factor will becomes equal to how much? 1. Here n factor will becomes equal to how much? 5. Here n factor will becomes equal to how much? 3. Like this, n factor is nothing but the number of active species generated from one molecule is said to be n factor. Corresponding gram equivalent weight, suppose in this case if you want to calculate, this gram equivalent weight will becomes, in this case, that is gram molecular weight divided by 1. In the second case, that is gram molecular weight divided by 5. In the last case, this is gram molecular weight divided by what? 3. So therefore, from here one particular issue becomes very clear for us, that is gram equivalent weight is the weight of substance that is responsible to produce one Avogadro number of active species. If I rewrite, if I say, if I correlate the things and the interrelations between the gram molecular weight, gram equivalent weight, n factor, and individual clear definitions for all the things, they appears as, yes, here once again, gram equivalent weight in the first case as being n factor is 1, that is gram molecular weight by 1. In second case, n factor is 5, hence gram molecular weight by 5. In third case, the n factor becomes equal to 3, hence this is gram equivalent weight by 3. Here, equivalent weight for a particular substance never remains same as well as constant in every instant, because if it is having a chance to show many varieties of oxidation states on behalf of the initial and the final oxidation states, on behalf of the change in oxidation number, n factor changes. As n factor changes, the corresponding gram equivalent weight also varies. We never say as a rule that the corresponding gram equivalent weight of every substance in every particular reaction, irrespective of medium, remains same and constant is not valid. It may vary depending on the conditions, reactions conditions like medium, acidic, basic, neutral, etc. Now, if we write the relations and the interrelations, thus gram molecular weight will becomes equal to gram molecular weight becomes equal to n factor times of, what will happen? N factor times of gram equivalent weight. N factor times of what? Gram equivalent weight. So in general, gram equivalent weight will be smaller compared to the gram molecular weight with some multiple of n factor times. If you do, n factor times of gram equivalent weight will becomes equal to gram molecular weight. As we said, gram molecular weight is weight of Avogadro number of molecules weight. If it is expressed in grams, is said to be what? Its corresponding gram molecular weight. Gram equivalent weight, the weight of one Avogadro number of active species producible amount of starting materials weight expressed if in grams, that is said to be what? Gram equivalent weight. Whereas this particular n factor is the number of active species produced from one molecule. Otherwise, the total number of the many Avogadro number of active species produced from 1 gram molecular weight of substance is also said to be what? N factor. So therefore here gram equivalent weight will becomes equal to, from this once again if we readjust, this gram equivalent weight will becomes equal to gram molecule weight divided by N factor. This will becomes equal to gram molecular weight divided by what? N factor. Yes, gram equivalent weight will becomes equal to gram molecular weight divided by N factor. Whereas N factor in terms of general redox reactions, in oxidations, in reductions, in complex redox reactions like calm proportionation reactions and the disproportionation reactions, how it will be present. Suppose if we go for the two cases, case number one, that is in simple redox reactions, whereas in complex redox reactions, how this N factor is present, let us have a discussion. Suppose if a material is maybe can be oxidizing agent, a reagent that can be acting as a reducing agent, then this N factor will becomes equal to change in oxidation number of the central atom. Change in oxidation number of central atom will becomes equal to this particular N factor. Whereas if it is a complex reaction, like the same material is undergoing oxidation and the reduction, that is same element is undergoing oxidation and the reduction, then that is known as what? A complex redox reaction. This can be a calm proportionation reaction, that can be a disproportionation reaction. Suppose the same material is undergoing oxidation, the same element with the intermediate oxidation state, some part of it one underwent oxidation, some other part of this one underwent reduction within the same reaction. In that case, individually we have to identify the oxidation number of the first one, oxidation number of the second incident. So therefore the net N factor will becomes equal to N factor of oxidation plus the N factor of what? Reduction. So if I add 1 by N factor will becomes equal to 1 by N factor of oxidation plus 1 by N factor of reduction. This reciprocal value will becomes equal to what? N factor. That N factor will becomes equal to the regular N factor. Thus N factor will gives an idea. N factor will gives an idea, that is the for the exchange of 1 Avogadro number of electrons. Suppose if it is a normal simple redox reaction, for the exchange of 1 Avogadro number of electrons or the masked form of electrons, whatever weight is required, whatever weight is otherwise from 1 gram molecular weight, how many, otherwise from one molecule, how many of active species are going to be produced, that is said to be its N factor. N factor regularly will becomes equal to change in oxidation number in case of simple redox reactions. If it is a complex reaction, that is calm proportionation, disproportionation, both oxidations and reductions, if they are occurring at once within the reaction, then this N factor calculation maintains a relation, that is 1 by N factor will becomes equal to individually N factor of oxidation plus 1 by N factor of reduction summation with the reciprocal value results the N factor involved in the transformations. Thus N factor value is calculated. With this, it might clear for everybody of you, that is gram molecular weight, the weight of Avogadro number of molecules, if it is expressed properly in grams, is said to be gram molecule weight. You can express in other units also. Whereas the weight of substance which is capable to produce 1 Avogadro number of active species is said to be gram equivalent weight. The number of active species, those are going to be produced from 1 gram molecular weight, otherwise one molecule is said to be number of electrons, number of active species produced from one molecule, otherwise number of gram electrons, that is set of Avogadro number of, the many number of Avogadro number of active species, those are going to be produced from 1 gram molecular weight of substance is said to be its corresponding N factor value. N factor in normal redox reactions becomes equal to change in oxidation number. The magnitude is taken. Generally, in these cases, it becomes equal to a number. In some other cases, it also becomes fractional value. That is a different case. Suppose the special case of redox reactions, that is complex redox reactions, in which both oxidations and the reductions are present. In that cases, you have to calculate the change in oxidation number for the balanced format for the oxidation, balanced format for the reduction, whereas those are N factor of first half plus N factor of second half. The reciprocal summation of these two N factors of oxidations plus N factors of reduction becomes equal to 1 by N factor of the reaction. Thus N factor of oxidation, N factor of reduction, N factor of complex, N factor of acid related reactions, acidity related reactions, base behaved related reactions and the salt related reactions, and other cases, these of are generally going to be calculated.